Hey everyone, Andrig with Andrig's Aircooled technology. This is going to be maybe a multi-part thing. I'm going to talk about cooling fans and some of the differences between them and what I'm doing in terms of my design to get better performance and have a more robust fan in terms of mounting and all that. So first two things we're going to cover the early VW fan and the Porsche 356 fan, which most people think are identical to each other, and they are not, and they do perform differently. But we'll talk about early VW, so pre 1971 doghouse fan shroud and the wider fan. So this is one of the early VW fans. Looks basically the same as any doghouse cooling fan, but just thinner. So the blade width on these I think are 28 millimeters. That doesn't count the thickness of the top and the bottom. So just the actual blade. It has a very particular curve. There's 28 blades on it. Has the same mounting solution that all Volkswagen fans have, and have just the two holes here. Which are primarily just for allowing the fan to pull some air from this side, from the alternator / generator. So, and of course these would all have generators on the back of them, but unless you've upgraded obviously your car to an alternator from a generator. But that's what those are really for, is to allow some air to pull from this side, not just from the inlet side of the fan shroud. And it's a relatively straightforward design using an arced blade design, and they work actually really well. Contrasting that to the Porsche fan is a Porsche 356 fan. So it looks like on the surface, hey, aren't they identical to each other? If you put them kind of together, right, they're the same diameter, 230 millimeters. They've got the same exact blade height, and the blades look and virtually the same, although there is some subtle differences in terms of how these things are put together. And they have a lot of holes. They have 8 holes, large holes. So obviously that serves a similar purpose on the Porsche 356, allowing the generator to pull some air, but they put a lot of large holes really just to make the fan a little lighter. Is primarily the reason they have more holes. The interesting thing, though, contrasting these two, is that the blade curve is opposite. So these curve this direction, and I don't know if you can be able to really tell that these curve the opposite way. I don't know really why Porsche, with a higher performance, engine, higher horsepower engine in the car, decided to actually use blades curved the opposite direction. That's actually less efficient, and it moves less air than what Volkswagen did for a much lower horsepower engine. So not really sure why the engineers made that choice, but it is different than VW. So, and that makes a real difference in kind of the airflow numbers. And I've measured these things, and this really does produce quite a bit less air than the Volkswagen one. So, so one thing a Porsche 356 person could do actually to improve the cooling on their 356 engine is actually use the early VW fan. It would actually do better. But I don't think Porsche people like doing that. That's for sure. So they want Porsche parts on their Porsche car, which I can fully understand why they would want to do that. But there is a difference between them, and the difference actually is, performance-wise, in terms of airflow, is worse on the Porsche 356 fan. So interesting that they made that decision. So here is the prototype for lightweight cooling fan version. This is the final prototype. This will be what goes into production, And you'll notice some differences on this. Some of these differences that are here are not really noticeable to the naked eye. So we've got the same, two holes. Not really worried about, trying to make this lighter. It'll just be a lot lighter just because of the material, etc. Obviously, it'll be one piece. It won't be, a 28 blades with the top and bottom and put together. This will be one piece. This can be 3D printed, just like this is 3D printed, but just with a much higher end industrial 3D printer. Not that this wasn't an industrial 3D printer, it is actually a pretty high end industrial 3D printer. It just can't print the kind of material that is needed for this, for a production application, to actually sit on an engine and be strong enough and be heat resistant enough and chemical resistant enough. But this works perfectly great in just a electric motor setup that's behind me that I explained in another video. But what's different about this is my arc is in the same direction as the Volkswagen, not the direction of the Porsche, because we want that efficiency. But my arc is different. These blades, actually, what's really interesting about what Volkswagen did on these blades is it's actually not a complete arc. It actually has a small arc on each end, and it's flat in the middle, which is really a manufacturing consideration, right? Because you basically have these like pieces that stick up in the fan that are pinched together. That's what's holding this together. On the doghouse fan, they actually changed this where there are two tabs, and the tabs are twisted. And of course, you buy a welded fan, all they're really doing is on these things. Hopefully, you can see that. Well, on these things, all they do is weld that right there. And they don't even weld all of them. They just weld like one of them on each side. I've seen them, even the welded fans, fly apart, especially for people who are using what's traditionally called serpentine, belt systems. They're really poly V belt because they can transmit significantly more horsepower. So the belt slippage happens at a much higher RPM. So you actually start spinning the fan faster at high RPM. And of course, the faster you spin something, the more likely it is to fly apart. So all you got to do is have a crack in one of those welds or whatever, and one piece lets go, and it'll start, being shrapnel for other things. So same direction, but mine is a different arc, and it's a complete arc, which actually helps with the efficiency of the fan. And then mine is taller, so I did increase the blade size. How I did that really was redesigned the backing plate so that I could get more room in the fan shroud, in the existing fan shroud envelope to do that. So it's not much more bigger. In fact, the blade height difference isn't so great that's what explains really the difference in performance. And I'll be publishing these numbers. The other thing that's really important for performance is really the inlet and this arc on the top, leading to smooth and lower pressure airflow into this. And while you probably could never really tell the difference between those in terms of anything, in terms of the arc or that entry, it is different. It took me probably 10 different iterations to really get that arc optimized really well to get higher airflow, and that was really the thing that kind of unlocked the performance of this fan. The one other thing you'll notice is the mount. Instead of the traditional mount style, I'm developing my own mount, which for a lot of reasons. One is on higher performance engines, these tend to wallow out. And on my original lightweight cooling fan, I used this pattern, but I created a cup version of it because of the way the fan geometry was. I could do that. Created this, right? So it has the same internals, but this cup actually, supports the outside of that. and relieves a lot of the pressure that is on kind of those corners and edges. So at high RPM, you don't end up with, and this cup was actually a interference fit. So there was really very little stress. I relieved the stress on that quite a bit. But in going back to a squirrel cage fan, thinking about this, I'm like, well, I don't really want to go back to using the stock mount for this thing. Plus, I really can't do that with this design and making it bigger, what have you. If this center part is sticking way up, then it creates a restriction and creates some weird turbulent airflow, inside. So this had to remain fairly flat, like these are fairly flat. You can, in fact, I'm flatter in my design on the back side of this than the original Volkswagen fan. So I made a much lower profile, mounting system here, and this is kind of what it's going to look like here. So this is one of the prototypes. I actually have changed this since this one, but I'm waiting for it to be shipped to me right now as kind of final. But it has the same keyed thing. It slides on the alternator regenerator just the same way, but then I end up with 6 threaded holes that take some really tiny, I think I have them around here somewhere, but take some tiny bolts, socket bolts. Let me get those real quick because I'll show you that. They're over here. All right, I'm back. So much more like, so we'll just have this kind of thing right here, where you just, we'll have 6 of these, and they'll go completely flush in here, like so. It'll go completely flush, and then on top of that, and so this is still prototype here, will sit on top of that. There'll be a spacer, and there'll be a nut that goes like that, and smooths that out. In fact, this is kind of, I was doing it as one piece, so like this, where you could do like that, just a one piece thing. That's one of the prototypes, but I've decided to actually do it as just buy a standard nut instead of my own nut, and just have this spacer here instead. That's actually much cheaper to manufacture. These nuts are really inexpensive, and doing a spacer like this, and I'm going to actually incorporate a spring-loaded washer on here, so it'll eliminate also the need to use Loctite. So I bought those. I'm going to print another one of these that incorporates the washer, and then you'll have a mounting system that is more akin to how a flywheel is mounted. Where you got the studs and you got a nice gland nut. So more like that design, a lot less stress on this center, because the stress and forces are distributed across all 6 of those. And then of course, the final solution here in terms of locking that in place with the nut and the spacer is just going to give a very robust mounting solution, and you're never going to have to worry about it wallowing out. You never have to worry about it, coming loose, as long as you torque it right. So generally speaking, that's what that's going to look like, and I think it's going to be really nice. There's going to be more parts in this solution. There's going to be a backing plate, that just the one that goes behind. The front one will stay the same, and you can reuse that, but it'll come in the kit. And so for the Porsche 356 fan, we basically did the same thing as we did for early VW. And the internal dimensions of the 356 fan shroud for the fan itself are identical. So that part is the same. So this fan is basically the same dimensions as the early VW fan that I'm creating. But because I'm using the blades arced in the opposite direction, the difference is even greater on the 356 in terms of cooling difference. In fact, just this fan is better than the original fan with a velocity ring. And then when you add the velocity ring, it's even much greater. In fact, that's the other thing about the designs of these is with the velocity ring, they actually get a larger increase percentage-wise in airflow than the standard fans with the velocity ring. So, which is really good. So it just shows, the efficiency is much greater in terms of, these fans versus the originals, which was, like I said, it wasn't easy to do. But those are the first two. I'll talk about the doghouse fan in another video, and then I'll talk about the new cooling system that I'm creating in another video as well. So that's it for that. So it seems like those differences are really subtle, but this is, but that's what it takes, is really subtle, small changes to actually make a more efficient fan that will actually provide more air, and not just size. Size is a part of it. Obviously, they are a little bit bigger in terms of what can fit in the fan shroud, but the bigger thing really is the small, subtle changes. And of course, one other thing in terms of manufacturing these via 3D printing also allowed me to have blades that are rounded on the edges. These are just sheet metal parts that have been stamped into the shape that they're in, and of course they just have sharp edges on the leading side of this, which doesn't really help airflow that much. You want to avoid sharp edges, to get good clean airflow. So that's another thing, another advantage of doing it via 3D printing, is because I can actually, the whole profile of this blade is actually different. It's rounded on the front, and that allows me to do that. I couldn't do that if I was, stamping these things out of steel, or even trying to do like titanium or aluminum. Some people have asked me, why not do aluminum? Well, the materials that I can use for 3D printing are about as strong as aluminum, and are still lighter than aluminum. And I don't have to do stuff like making something like this out of aluminum means essentially that you're doing the same thing. You're cutting up a whole bunch of, having a whole bunch of parts cut and shaped and stamped, and then fitted together, and you don't have to weld that stuff, right? So a lot of extra money and time to do that, and the tooling cost is also very expensive, much more expensive than 3D printing. So this is just the wave of the future. Is things are going to start being 3D printed more and more and more, and investing in that pretty heavily. Been doing that with prototyping for a very long time already, since the start of the business, and we'll continue doing that. But now production parts will start being 3D printed. Better than injection molding. The tooling cost there is really expensive as well, which is what I did for the first version of the lightweight cooling fan. So I'm trying to get away from that, and of course that lets me do the manufacturing completely myself, which also is saving me money as well, and then consequently saving you money. Although the material costs, like everything right now with inflation the way it is, material costs are going up. So not really sure what price point I'm going to be able to hit just yet until I have the machine. But I got good news today, actually, which is September 8th, that they are getting ready to ship my machine for 3D printing these things. So that's awesome. So hopefully we'll be up and running fairly soon, and starting to produce these products in mass, and be able to get them out to you guys. So thank you for all the business. A shout out to the Old Folks TV guys. Jason, appreciate you covering my products in your videos and writing tech articles and everything you've done. It's definitely spread the word on my products and helped me a lot. Really appreciate that. Thank you. Thanks to all the customers out there. You guys have been great, and we'll talk to you again soon.